For this lesson, we're going to talk about how to find vertical and horizontal asymptotes algebraically. Remember, asymptotes are basically invisible lines on a graph that your line that you're graphing is never going to cross. They almost act like invisible barriers. You don't actually see them if you go to like a graphing calculator and you go to graph out some function. If it has an asymptote, you're not going to see an actual line showing that on the graph. You will just see that the line of your graph will just suddenly bend away from a certain point, from a certain place on the graph. And that invisible barrier would be an asymptote. Now, we're not talking about what it looks like graphically or anything with this lesson. All we're talking about is how to find what they are algebraically. We'll deal with graphing another time, okay? To begin with, let's talk about vertical asymptotes. I think those are the easier ones overall. Vertical asymptotes are pretty straightforward. First off, if you have a vertical asymptote, it will always be x equals something. It's always going to be x equals something. Okay, if it's y equals, that's a horizontal asymptote. So anytime you're asked for a vertical asymptote, you can already know or assume that it will be x equals something. Your job is just to figure out what that is that x equals. Okay, the way you do that, as you can see from the directions right here, is you are going to take only the denominator. We only worry about the denominator. Remember, that represents the bottom of a fraction. So if you have a function, a rational function, which that's the chapter we're in here, if we have a rational function, when you want to find the vertical asymptote, you only look at the bottom, only the denominator. You're going to take whatever your denominator is, set it equal to 0, and solve out. So, for example, if I gave you the function f of x equals 1 over x plus 3. Okay, if I gave you the function 1 over x plus 3, what is the denominator of that function? Well, its denominator is x plus 3. So we would take that denominator of x plus 3 and we would set it equal to 0. And then the only thing we have to answer is, how do we solve that? Obviously, depending on what the denominator was, every time you're going to have to solve a little differently, but you know how to solve equations out. That's what you've been doing through this whole class of Algebra 2. You've probably done Algebra 1, that sort of thing. So in this case, the opposite of addition is subtraction. We would simply need to subtract 3 to the other side, which would tell us that we have a vertical asymptote, which I abbreviate vertical asymptote as VA. We have a vertical asymptote of x equals -3. It is important that you understand your answer is not -3. If you said your vertical asymptote is simply -3, that would not be correct. Asymptotes are lines, not just numbers, so they will always need to be expressed as equations. In this case, your equation is x equals -3. So that entire equation is your answer. Now let's talk about horizontal asymptotes. Now the good news with horizontal asymptotes is there's pretty much no algebra involved. You don't really have to do any like actually solving out for a variable. So in that regard, it is less work, as in less stuff you have to write down. However, I consider horizontal asymptotes to be the tougher of the two, because as you can see here, there are multiple different scenarios that can happen, and you have to remember rules based off each scenario. You may want to pause the video here to copy down everything you can see here on the screen and then hit play again once you've written that down. As you can see here off these definitions, the first thing you're going to want to do is to find the degree of the numerator and the degree of the denominator, meaning top and bottom. Remember, we've talked about degree before. Degree is the highest exponent on your variable. Degree is the greatest, the highest exponent that you have on your variable. And you are going to look at the top and bottom, the numerator and denominator of the function, of the fraction, separately, as if they're two separate pieces. So you'll look at everything in the numerator, everything on top, and determine what is the greatest exponent we have up there. Then you'll look at everything on the bottom, everything in the denominator, and determine what is the greatest exponent we have there. Then, depending on how those compare to each other, will determine which of these three cases you have. Now, first off, let's go ahead and go through each of these different cases. So case 1 is that the degree of your numerator, the degree of the top, is less than the degree of your denominator, the degree of the bottom. If that's the case, every single time your horizontal asymptote will be y equals 0. Yes, it really is that straightforward. If you have determined that your numerator degree is less than your denominator degree, every time your horizontal asymptote is y equals 0. Let's talk about the second case. Let's say your numerator degree is equal to your denominator degree. Well, if the degree of your numerator is equal to the degree of your denominator, you have to do a little bit of work, not much, but a little bit. What you have to do, and don't freak out by the amount of words there, it's not as bad as it looks. You find the leading coefficient of the numerator, and you divide it by the leading coefficient of your denominator. Remember, a coefficient is a number in front of a variable. The leading coefficient is specifically the number in front of the variable that had the greatest, the highest exponent. Meaning whatever number you got your degree from, whatever x you got your degree from, take the number in front of that on top and bottom. Last but not least, we have the third case. If your numerator degree is greater than your denominator degree, if the degree of your numerator is greater than the degree of your denominator, then you actually don't have a horizontal asymptote, you have a slant asymptote. Now later on you may be asked to find slant asymptotes. I'll make a separate video if necessary about how to find slant asymptotes, but for now, if you were asked to find a horizontal asymptote, technically the answer would be that you have no horizontal asymptote. You don't have one because a slant is not horizontal. It's diagonal of some kind. Okay? Now, to give you a couple examples of these different types of asymptotes that you could see. Let's say I gave you the function f of x equals x squared over x to the third plus 5. Let's say I gave you that for a function. So what you'd want to ask yourself if you want to find a horizontal asymptote is you want to ask yourself, what is the degree of my numerator, the degree at the top, and what is the degree of my denominator, the degree of the bottom? Well, on top, the highest exponent I see is this 2. So it has a degree of 2. In the denominator, the highest exponent I see is this 3. So it has a degree of 3. Well, if the top has a degree of 2, the numerator has a degree of 2, and the denominator has a degree of 3, 2 is less than 3. So the numerator degree is less than the denominator degree, which means this would be an example of a horizontal asymptote of y equals 0. Again, remember it has to be the full equation. It's not 0. It is the equation y equals 0. That's the easier one. Let's talk about case number 2 where you have to divide the leading coefficients. Let's say, just box off the little thing here. Let's say I give you a function of f of x is equal to 4x plus 3 over 2x minus 9. Again, you would want to find the degree of the numerator and the degree of the denominator. Well, if I look at the numerator, I see an x to the first power, right? If they don't show me an exponent, there's really a 1 there. That is the only variable I see, therefore it must be the greatest exponent, so it has a degree of 1. I also see only a 2x to the first in my denominator. I don't see any other variables, so that must be the variable with the greatest exponent. So both numerator and denominator have a degree of 1. That would mean they are equal. So in order to find my horizontal asymptote, I would need to take the leading coefficient of the numerator divided by the leading coefficient of the denominator. Well, the leading coefficient of my numerator would be this 4, because that's the number in front of the variable with the highest exponent. Likewise, the leading coefficient of my denominator would be 2, because that's the number in front of the variable with the highest exponent. So, that means my horizontal asymptote for this, it's always y equals, and this time it'd be y equals the leading coefficient of the numerator, aka 4, divided by the leading coefficient of the denominator, aka 2. What is 4 divided by 2? It's simply 2. So our answer would be y equals 2 for the horizontal asymptote of this example. And then real quick, I guess to give you an example of case 3, let's say I gave you the function f of x equals x to the third over x squared plus 3. Well, that's a degree of 3 in the numerator, and that's a degree of 2 in the denominator. Since 3 is greater than 2, that would mean you have a slant asymptote, or in other words, you would say you have no horizontal asymptote at all. Obviously, you can have much more complex functions that are harder to solve out, but these are the basic rules that you need to be able to follow to find your vertical and horizontal asymptotes.